现在将录制本次会议。
Okay, good morning, everyone. Let me just switch on my camera quickly so everybody can see me. Okay, so today we're going to be talking about a few solutions that's available on the Hytera DMR conventional systems. We'll specifically focusing on the IP multi-site sub-connection. We'll talk about a little bit about XPT, and then we'll talk about NMS, and then we'll go through some of the solutions. I'll discuss in detail how it's possible to have these solutions and what's needed. So thank you so much for everyone for joining. Okay, so let's first maybe start with the different systems that is available from Hytera. So if you guys look at this slide, you'll see on the left hand side we have a DMO, which is direct mode operation. That's if it's radio to radio, there's no system or anything. Then we have what we call RMO, which is repeater mode operation, where you've got a repeater and you've got radios connected and talk through the repeater. That gives you expanded coverage. Then we have what we call IP connection, which is IP multi-site. This is similar to RMO, but the only difference is here you've got multiple repeaters that are connected over an IP network to expand your coverage even further. Then we have what we call simulcast. Simulcast is a like almost similar to a IP multi-site. The only difference is with the simulcast is that you've got multiple repeaters that also connected over a IP network, and they share the same frequency across the network. So if someone talks into one site, it will transmit that same frequency across the entire network. We also have what we call XPT. So XPT is extended pseudo trunk. It's a proprietary system which is similar to a trunking system, but the radios would use the pseudo trunk function to switch between different time slots as well as different repeaters on a single site. There's no control channel. The radios, the intelligence are in the radios for it to be able to switch between the different channels. And then we have what we call trunking light and then trunking pro. So in next week's session on Tuesday, I'm going to be talking about trunking light and trunking pro. You'll see on a trunking light system, typically you can have up to 50 sites. And on a trunking pro, you can have up to 256 sites connecting to an MSO. This can also be expanded. I'll explain it when we do our session next week on the trunking systems. Okay. So if we look at, sorry, I just want to move the screen a little bit. So if we look at the DMR products that we have, like I mentioned in the previous slides, the radios and our equipment can operate as analog, and they can also be programmed in DMR mode. If you introduce a repeater into the system, it will give you bigger coverage compared to operating in a direct mode operation. And then if you need to expand on that, you can then convert or change over to IP multi-site. So just to highlight again, so you would use your radios in direct mode operation, limited coverage. If you introduce a repeater, you expand your repeater coverage or your communication coverage. And then if you need to expand on that, you can then add an additional repeater and link the two repeaters using IP multi-site. And then if you need more traffic or more channels on your system, you can then upgrade that existing repeater to an XPT system. And then also you can then also from the XPT, you can also upgrade to tier 3 light. So if we look at IP multi-site, so with our solution, you can have up to 226 sites connected over an IP network. Normally, how it would work is you would have a master repeater, and that master repeater can support up to 29 slave repeaters. But you can also program the system to have a master, a sub-master, and then slaves. And every master or sub-master can support up to 29 slaves. So for example, like this picture here, so you've got an area A, you've got multiple repeaters deployed in this area, and you want some of these radios in this region to be able to talk to an area B or an area C. So if you have IP backhaul, an IP connection, it's possible for you to be able to expand your coverage, and you can have up to 226 repeaters connected over a IP network on a conventional tier 2 system. If, let's say, you have to or you need to upgrade the system, you can then also, if it's an RD985S repeater, you can also upgrade that repeater to operate as an XPT system. So you normally get what we call XPT single site, and then you get XPT multi-site. So on an XPT single site, you can have up to 8 repeaters, which gives you 16 channels. And if you go on an XPT multi-site, you can have up to 16 sites with 8 repeaters per site. And then you can also interface it to a telephone system. You have dispatching capabilities. And then there's also a network management NMS, which is software for you to be able to manage the network as well and see all the stats and all that from the network. So I did discuss the smart dispatch on Tuesday. So smart dispatch is for conventional, so it works with a conventional system. It can be used with an IP multi-site, but if you're going to upgrade to an XPT system, you would then need to use the smart one for XPT, which is this one here at the bottom. The benefits of the smart one for XPT is you could also interconnect this into other systems. So for example, let's say if you want to interface it to a mid-band or air-band, there's a wireless gateway, which is called the MPUC, which has inputs on it where you can then interface a mid-band radio using an ENM connection, or you can use an MD785 to connect to the wireless gateway, and that MD785 can be programmed as an analog radio, as a MPT radio, or as a tier 3 radio, even if you want to talk into a tier 3 trunking system. So that's the benefits of a smart one dispatching system versus smart dispatch. Okay, so if we look at this here, so this is the XNMS. XNMS can also be used on a conventional system. So the benefits of using XNMS is for you to be able to manage and monitor your network. So from this specific slide, you'll see you can also have a network topology, which will show you all the repeaters that are connected to the XNMS. You'll be able to see what services are being or which traffic is going through the network. For example, you can see how much data, how much voice, how much, and you can also from this you can also monitor to see if a specific site is being underutilized, and some sites might be overutilized, so you can then move some of the resources to give more capacity at specific sites and less capacity at certain sites where less traffic. So you can also monitor the parameters. You can make some changes as well through the XMMS, so you can change frequencies. You can change some information inside the repeater. You can also access the what we call access manager, or you can say specific groups need to talk locals, certain groups need to talk through the network, and you can manage all of that through the XNMS software. You can also do reports, so you can query data, you can see all the data that went through your repeater sites, and you can also extract it into an Excel format. And then also the stats and reports. So like I mentioned before, like this service monitor, here you can actually pull stats and see which sites are more busy, which sites are less busy, and you can have full-on visibility of traffic that's going through the network. It also has the capabilities for you to have what we call RSSI map. So that's radio signal strength indication on a map. So if you have certain radios and you want to see how your coverage on your signal strength, the software will also record this information, and you'll have visibility of the signal between the radio and the repeater. If you see there's certain areas where the signal is weak, you could look at either deploying another repeater to cover that region, but you can also have it visibly available on the map to show areas where signal is good and areas where signal is bad. Because what's happening with this here is the radio receives the signal from the repeater, and there's a level for that signal strength, and it will then send that data to the repeater, and the repeater will send it onto the NMS software, and it will record that information. Okay. There's also a separate software which is called OTAP, which is for over-the-air programming. So let's say if you don't want to have smart dispatch and you only want to use the OTAP function, we do have a separate software that can cater just for OTAP. So you'll also still be able to do the same as what you can do from smart dispatch. For example, you can do change the frequency on the channel, you can change the radio ID, you can do minor changes over the air. Just note that you can't do all the programming that you can do from the programming software. Okay, this is typically a diagram of how you would interconnect a repeater directly to an IP telephone system. So you'll see on the left-hand side here, we've got repeaters. They are all connected over an IP network. Here we've got an IP telephone system. So how this normally, or how you would do this is inside the repeaters programming, you would give the IP address of the SIP server. And then on the SIP server here, you would create extension numbers. And these extension numbers you'll then capture inside the repeater. It will then register to the IP telephone system. Oh yeah, okay. If there's any questions, you guys can just stop me and ask. So yeah, so the repeater would register with these extensions here, and then inside the repeater, you can then, every extension can then be forwarded to a specific radio ID or to a group of radios. Let's say if a radio is switched on, it will send its online status to the repeater. If that radio ID is linked to an extension number on the telephone system, it will then make that extension online. If the radio is switched off, it will then go offline here or deregister that extension. So if someone had to phone from a cell phone to the telephone system, if this radio isn't online, it will just then not be available for you to phone the radio. It will say that the telephone is offline. You can also from the radio dial out into the public network. So what the radio does is it uses DTMF signaling. So it will then send a DTMF signal to the repeater. The repeater will then decode it to a SIP protocol, which will then send that information to the IP PBX, which will then dial out either to an extension number connected to the same telephone system or to a cell phone number via a VoIP provider or a telecom, which will then go into the public network. Okay. Any questions anyone have? I'll go on. Also something to highlight is on the repeater here, you can have up to 30 extension numbers that can register to the SIP server at the same time. So you can have 30 different extension numbers linking to 30 different radios or groups in the system. Just take note that because the repeater only has 2 time slots, you can only have 2 conversations happening at a single point in time through the system. Because a telephone is a full duplex call and a radio is a half duplex call, if you do not PTT from this radio, you will receive the audio coming from the telephone, but when you PTT from here, the person on the phone will hear you, but you won't be able to hear them because the audio is only going in or out on the radio because of it being a simplex communication or half duplex call, and this is a full duplex on the cell phone. If you are using the PD985 or the MD785, which is the full duplex model, you are able to utilize both of the time slots for you to be able to do a full duplex call to a cell phone number. But then also take note that while you're doing this, the repeater slot 1 and slot 2 will be busy and nobody else will be able to access the repeater for that time. Okay, any questions? Am I going too quick or is it fine? Okay. Right, so just also to mention is that we as Hytera, we manufacture two-way radio terminals. We also manufacture the network part, which is repeaters, but we also develop our own applications here. So all of this is developed in-house by Hytera. So there's no third party that is involved with any of the developments of the dispatching. We do support third-party applications. We do have an API available on the smart one where we can share that information if a company wants to do their own third-party applications and want to develop their own software to interact with the Smart One or pull information into Smart One. So we've got the applications at the top. So you'll see we've got Smart Dispatch, which is for conventional, Smart One, which can work with XPT or Tier 3 or with Tetra. And then we've got OTAP and XNMS here, which is for you to be able to monitor your network. We also have another software called NMS, but when we discuss the trunking on Tuesday, I'll explain more about the NMS. For networking, you've got your conventional repeaters here, so you can have either RD985 or RD985S. If you have a RD985S, you are able to upgrade the same repeater to an XPT system, and you can also upgrade that same repeater with a license to a Tier 3 light system. And then for our terminals, we have from conventional to mid-tier, which can support MPT or Tier 3, and then we've got our high-tier models, which can support all these networks. Okay, I did explain the SFR functionality before, but I'll explain it again. So on the PD985 and the MD785, the duplex model, there's a license that you can buy which is called an SFR. SFR stands for single frequency repeat, and this would allow for you to be able to expand your coverage in simplex or direct mode operation. And how it would work is, can we network with RD625? Yes, you can. The RD65, which is a discontinued product, that's still compatible with the RD985 repeaters. So if you have an IP network and you have some RD65s, they are able to communicate and connect with RD985 or 985S repeaters over IP multisite. Okay, so if we look at this example here, if let's say you've got a radio here and you're transmitting from this radio on slot 1, and this signal doesn't reach this radio here, if you have a SFR portable or mobile close enough to receive this signal, but also close enough to be able to transmit to this radio, it will receive the signal from this radio on slot 1, and it will retransmit the signal to this radio on using slot 2. So it works similar to a repeater, but it uses the 2 time slots for you to be able to receive and transmit. So it can give you extended coverage if you have a SFR radio. As long as the SFR radio is in between the 2 radios, and this radio can receive from this radio and it can transmit and reach this radio, you will be able to communicate via SFR to another radio which is too far away from this radio to receive it. We have the PD985 in VHF and UHF available. So you can offer a solution like this to a VHF or a UHF customer. We also have a MD785, which is a duplex model, and this can also be used to achieve the same functionality. A typical example where you would use an SFR, I know we've had some good success using these on farms, where a simplex frequency doesn't reach all the areas of the farm. But if you had to deploy an SFR mobile somewhere in the center or in a building with an external mobile antenna, you will have repeater-like coverages using a simplex frequency. We've solved a lot of problems with customers that had coverage issues using simplex, and where we've introduced an SFR into the solution. Note, this only works in digital mode. It can't be used in an analog radio because it needs the 2 time slots in TDMA and DMR for you to be able to have this function. Note that when this radio receives the signal on slot 1 and it's transmitting on slot 2, this radio needs to be able to receive a signal from slot 1 or slot 2. On the Hytera radios, you just enable the pseudo trunk function and the radio will dynamically receive on slot 1 and slot 2. If you have other existing DMR radios and you want to still use this function, you can do it, but you would need to program this radio to be able to scan between slot 1 and slot 2, so that if the signal isn't received on slot 1, that radio must be able to scan and receive the signal on slot 2. Okay, any questions anyone has? Okay, so this is the SFR function. It's a very nice solution, especially for customers that are not able to achieve the coverage they want on a simplex frequency and do not want to pay for a repeater or apply for duplex frequencies, this is a quick and easy solution to solve that problem. And you can use BD505s or PD405s. Any of the Hytera portables can be used, and it will work seamlessly on the SFR solution. Okay, here's another solution that I'm going to explain. So let's say if you are wanting to link two repeaters and there's no IP connection available between the two repeaters, you are able to create a link using two mobile radios. Note that these two mobile radios are not communicating to each other directly. So how it would work is if I had to transmit from radio 1 on slot 1, this repeater will receive the signal on slot 1 and it will rebroadcast the signal on slot 1 for this area where the repeater is. But also take note that this signal will also be transferred to the mobile radio, and this mobile radio will transmit the same signal with all the information of this radio data, everything, and it will then retransmit this signal over slot 1 to this repeater, which will then rebroadcast the signal this side. You can do text messaging from here to this repeater via this mobile. It will have all the information of this radio. All of that will be forwarded to this mobile to reach this side. And also, if let's say I wanted to do a private call from this radio on slot 1, I can talk to a radio on this side on slot 1. And you'll see also, again, from this side, if I was transmitting from radio number 3 on slot 1, it will then be received by this repeater. It will retransmit it. This mobile will receive it on slot 1. It will send the information to the repeater, and the repeater will then transmit that same signal out on slot 1, and I'll be the radio on that side will then receive the signal on slot 1. If we had to use slot 2, so let's say radio 4 here, I'm transmitting on slot 2. It will be received by the repeater. The repeater will repeat that signal locally from the repeater. It will also send that information to the mobile radio, which will then retransmit that signal on slot 2 to repeater number 1, and it will rebroadcast that signal on slot 2 on this side. So you have two slots that can achieve the same as what you would achieve if you had an IP link between the two repeaters. So there's no limitation or there's the intelligence are there. So it's not just audio going through, it also will forward the data. If it's a text message, if it's GPS data, all of that will then also be transmitted from one repeater to the other repeater with this type of solution. Where this is a handy solution is, let's say if you have two sites, there's a mountain or something between the two sites, so you can't get line of sight point to point, but this repeater signal can reach the other side and the other repeater can reach this side. This is a good solution for you to be able to link two repeaters at two different locations and don't have line of sight between the two. Is there any questions anyone has? Okay. All right. Just also another way you can do it. So let's say you are connecting more than two repeaters. There's IP connection between repeater number 2 and repeater number 3, but there's no IP connection or link between repeater 1 and repeater 2. You can use this mobile solution to link these two repeaters. Then you can use IP multisite to connect to the third repeater, and then you can use another mobile for these two sites to be connected. And then let's say if there was another IP site here, you could connect this again to another repeater over IP, and then you can have another mobile connecting to another repeater on another location. So just to show you that you don't always need IP multi-site or IP connection to be able to link repeaters. You can also, if it's for two sites, you can have two mobiles and you can achieve the same communication with two time slots between the two repeaters as well. Is there any question anyone have? Am I going too quick? Okay. Okay, so I want to leave this next half an hour for any questions, for any requirements, for anything that anyone wants to ask. Okay, let me see the question. Okay, so Joe asked previously, will radio 1 and radio 3 be able to connect and talk with the SFR radio? Is busy talking with someone else. Okay, Joe, so to answer that, so if you are using the radios in direct mode operation, if one group starts talking on slot 1, the SFR radio will receive that signal and it will retransmit it on slot 2. So while that is busy taking place, if a second group wanted to talk, they will not be able to communicate because there's already activity on that channel. So once the group call is finished, the next group will be able to talk, or the next radio will be able to talk. Anything else? Any questions? I also want to share some information. So I've got what we call application notes. These are notes that that I can share with you guys. I can share a link to you, and these application notes have a step-by-step guide how to configure radios to work in roaming, or how to configure a multi-site, how to configure a SIP interconnection. If there's anyone that is interested in getting these application notes from me, you're welcome to send me an email and I'll gladly share these application notes. I think there's about 60 different documents with 60 different guides on how to load a license onto a radio, how to configure a radio to do scanning, how to configure a radio to have specific functions. So there's a lot of applications that I can also share to you guys. Okay, today's session was a bit shorter than I thought it would be because I was expecting more questions. So if we look at the agenda and where we are so far, so we've completed the migration from analog to DMR. We've completed the Hytera terminals, the mobiles and portables. On Tuesday, we spoke about smart dispatch. Today, we spoke about IP multi-site SIP connection, XPT, and network management software. And then next week, Tuesday, I'll be speaking about the DMR trunking, the Lite and the Pro, and the differences between the two, and some functionality and uniqueness about our trunking solutions. And then we'll start talking about the multi-mode next week, Thursday, and we'll continue up until the 16th of September. For the people that have attended the previous sessions, if there was still any questions or anything that you guys still have, you are still welcome to ask any questions on any of this, and I'll gladly answer them. I'm sure there must be some questions. Any questions anyone have? There's also, for every session that we've had before, we have recorded these sessions. So you're also able to, if you are looking for any of these specific videos, I can also share the links to you guys to be able to go and watch them. If there's certain things that you want to watch again or want to clarify again, you're also welcome to ask me for those links. Is there anything that anyone wants to know? Okay, then I think if there's no further questions, then we can finish today's session, even though it was only a 30-minute session. I didn't think it was going to be this quick. Like I mentioned before, I was hoping to have more questions. Thank you so much, everyone, for joining. And if there's any other questions that you guys have, please feel free to contact me via email or telephone. And then also, let me just see, there's some other questions. Thank you. Mail you and give you a call next week. Sarah said, I would like to listen to today's session again. Okay, Sarah, I'll send it to you. Okay, then thank you so much, everyone, for joining. If there's any questions, please feel free to make contact with myself. I'll gladly assist where I can. Thank you.
Thanks, Franco. Cheers.
Cheers.
Dankie Franco.
Welkom.
Thanks, Franco. Bye-bye.
Dankie Franco.
Welkom. Bye.